Okay, in this video we're going to be doing Calc Problem Set 40, and the problems and a playlist are in the description below. Let's get started. We're going to find the derivative with respect to x of the natural log of sine squared of x. Alright, so initially when I did this I just dove in. I was like, I'm going to find this derivative, so it's going to be 1 over sine squared of x times the derivative of sine squared of x, which is 2 sine of x times cosine of x. This is totally fine. I mean, this gets you the answer. Not a big deal. You can cancel a sine, so we get 2 cosine over sine. And then cosine over sine is cotan, so you really are getting 2 cotan. Then I said to myself, wait, there was an exponent in a natural log, so I probably should have brought it out as the coefficient. Would it have made it easier? So if I rewrote it as d dx of 2 natural log of sine of x, yeah, I think conceptually it's a little easier, right? It's just going to be 2 times the derivative natural log of sine of x, which is going to be 1 over sine of x times the derivative of sine of x, so cosine over sine, which again is still just 2 cotan. You better get the same answer either way, but either of those would have been good. All right, new problem. Based on the table above, would you speculate f of x is concave up or concave down, and why? I feel like there's usually more to these problems when they're like on an AP exam, but since I was writing the problem, this is what I wrote, so I added speculate, because we don't really know, because, you know, there could be any number of, there could be an infinite maybe an infinite number of strange things happening between 0 and 1. No way to know. Maybe it goes up to 1 billion down to negative 1 billion. But based just on the table, what I'm going to do is just look at average rates of change, right? So from 0 to 1, it's 2. From 1 to 2, it's 4. And then from 2 to 3, it's 6. So that's our average rates of change. And if you look at those, the average rates of change are increasing. So like the slopes themselves are positive, but more importantly, the slopes are increasing. So since the slopes are increasing, I would say, think about that. That means like slope is the derivative. We're saying slopes are increasing. We're saying the derivative is increasing. If the derivative is increasing, the second derivative is positive, this is definitely concave up based on what we know in the table. So since the average rates of change are increasing, I'd say F is concave up. That's my best guess if I had to choose one. I do think we don't really know enough information. I should have like looked at an example problem from an AP exam or something to see how these are really written up, but I didn't. But I still think you can definitely speculate that this would be concave up. There's no evidence to suggest it's concave down. There's a lot of evidence to suggest concave up. All right, next problem. Given f of x equals g inverse of, I thought it was going to be something bigger, so that's why I was like all taking a deep breath. F of x is g inverse of x. Find f prime of 7 given g of 3 is 7, g prime of 3 is negative 5, g of 7 is 8, g prime of 7 is negative 10. What is happening? Oh, yeah, okay, so usually you're given, like, why are we given this information? Well, I guess the 7 is the important thing. Like, they're trying to screw you up with 7. Is it like g of 3 equals 7? Is that the important point? Or g of 7 equals 8? Is that the important point? That's what they're doing there. All right, so we do need to figure that out anyway. So we have 2 functions in play. We have f of x, and we also have g of x. In this particular case, we're trying to find f prime of 7. So 7 is an x-coordinate for f, for sure. And if 7 is an x-coordinate for f, and g is the inverse, then that means 7 is a y-coordinate for g. So 7 must be a y-coordinate for g. I always go through that thought process. Now what I'm going to do is look at the given information and figure out, okay, where is the y-coordinate 7 for g? So it's this first one. G of 3 is equal to 7, which means our ordered pair here is 3, 7 for g, which means 7, 3 for f. You don't actually need that 7, 3 ordered pair to solve this, I don't think, because you just need f prime of 7. But anyway, I always filled that in. All right, so at this point, we know f prime of 7 is going to be 1 over g prime of the corresponding point, so 3. And then if you look at the given, g prime of 3 is negative 5, which means we get negative 1/5. I love solving these problems. They're like free points on the AP exam as long as you like know what's going on. Take a second, think it through, make sure it makes sense to you. I have a lot of videos. I have a whole set of notes on derivatives of inverses. It includes the inverse trig functions, but like, you know, derivatives inverses heavily in there. Check them out. All right, next problem. Use calculus to find the absolute minimum of f of x equals 2x squared plus 3x minus 1 only on the interval from negative 1 to 1. All right, so absolute minimum in my mind is the candidates test, which hopefully you've seen at this point. to do the candidates test, you need the function to be continuous. This is a polynomial, so it's definitely continuous. So I'm going to say f of x is continuous on -1 to 1. So if you're continuous on an interval, then the absolute max and min must occur at either an endpoint or a critical point. So I'm going to write that down. The absolute by candidates test, absolute min at an endpoint or a critical point. I now need to find the critical points. So I need f prime for that. So f prime is going to be 4x. Oh, 4x. Uh-oh. Did I make this problem easier than it should have been? I think I did by making a mistake. All right, here goes. We're going to do it on the fly. Boo. It's my least favorite way to do these. And you can see, I mean, the quality decreases. What am I doing? All right, there we go. I got to erase some stuff. This should have been 4. Oh, man, I'm going to have to, like, find some stuff. All right, that's fine. Whatever. 4x, -4/3. That is in the interval. I originally had gotten it wrong, and I thought it wasn't in the interval. So I'm just going to say it's in the interval. That makes sense. I should have checked this, but I didn't. It's in the interval, which means when I make my table, I do need to include it. So I got to extend my table. Ah, boy. -3/4. Like that. And then when I plug in -1 and 1, I get -2 and 4. But when I plug in -3/4, I mean, this is a quadratic that opens up. You know that that's going to be the minimum, but now I need to, like, figure out that value. So where am I going to do this work? I'm going to do the work right here. 2 -3/4 squared plus 3 times -3/4 minus 1. Gross. All right, 9/8. And then let's say -18/8. Uh-oh, I ran out of room here. Uh-oh. I can't really see where I'm writing, and this is a problem. And then -1 is going to be -9/8 minus 8/8, -17/8. Disastrous. This is disastrous. All right, that's definitely the minimum. So then my explanation is not going to make any sense because the absolute minimum is not -2. It's not by much that it misses, but it's not. It's actually, I think, -17/8, and that's going to happen at -3/4. Crud. All right. There, I think that's the answer now. And, you were probably thinking that as we went along. I should have checked that one. I didn't check it. But anyway, I think this problem set is done. I hope this was helpful, and good luck.